we are recording. All right, so we're going to be finishing up the notes today on solving equations. And so we talked about what a solution is last time. Does somebody think they can tell me a little more accurately what a solution to an equation is? Anybody want to give it a try? Yes, sir. The final product, kind of. Yes. Yes, if you plug the number back in both sides, it'll make both sides true. So you're not finished until you got all the way to those numbers. Now, we're actually going to be working on some equations today that are just going to be a lot of variables. And we are going to be rearranging those equations so they're solved for a different variable than what they were already solved for. It's an important skill for higher math to learn this, and for some things we do later this semester. So we are on example 2 that's under the part solving, sorry. No, we did number 2, didn't we? We didn't with the J plus 9? Didn't we do that one? Yes, that's where we are. I don't know what happened to the other one, but okay. So we are on solving nonlinear. Oh, I know what's wrong with this thing. I'm sorry. I posted the.
So in your notes, when you post them online, you post 2. Are they both the same?
Okay, what I have online are the notes that are not filled in and the notes that are filled in.
Filled in by, you mean the answers?
Yes.
Okay.
And the reason I did that is so that students who are absent can look at the key. Now I'm also providing the video, okay? So I know what was wrong with my... For those of you that are watching this online, we had to move rooms because there was hammering and drilling going on. It was very exciting, but we didn't think we wanted to learn that way, so we have moved. So this is where we are, right?
Yeah.
Okay. So here we go. And I feel like I did one of these.
Yeah, you did the first one.
I did the first one, okay. So let's start with the second example. Now, the first example, remember, had a factor that was a constant. Do you guys remember that one? We factored out a 6 at the beginning. And since it's an equation, it is inconsequential because there's no way for 6 to be equal to 0. In fact, let's just remember real quick why factoring method works. So you guys are going to fill in the blank for me here. If you have a product, and I'm putting A times B, but this could be 5 factors, okay? If you have a product equals 0, then what has to be true?
One out of it is 0.
Yes. Then either A or B has to be 0. So when you're when you're doing your homework and when you're doing a problem where you're going to use factoring method, please return to this and go, okay, that's why it works. That helps me know what the process is. If I know what it's based on, then it's easier to remember the process instead of trying to memorize a whole lot of stuff, okay? So the problem we're working on now is to solve 2t to the third minus 10t equals t squared. So see, knowing that this is the true thing behind the method, I know I need 0. So the first thing I'm going to do is subtract the t squared from both sides. And there are no like terms, so what I'm going to do is I'm going to write this in descending order because it's usually easier to factor that way. So we're going to say 2t cubed minus t squared minus 10t equals 0. I'd like to play with the lights a little bit. Can you guys see this okay? It's actually good on camera. Can you all see it all right? Okay, we'll just leave it. It's still good there. So is that a little better for y'all? Yeah. Okay. All right, so what's that first step in all factoring?
Factor out a DCF.
Yes. Do you see one? What is it? Okay, there's not a 2 there. So just t. Okay. So just a t. And so we would be left with 2t squared minus t minus 10 equals 0. Now, I wanted to talk about this. This is a place to make a note in your notes, because the last example that we did on Tuesday, we had the situation where there was a factor that was a 6. Remember, we just divided it out, and I also explained that it's inconsequential because it's a number and it can't be equal to 0. But this is a variable, so you don't want to divide out variables, because if you do, you lose a solution. Okay? So don't divide by t. T is a factor here. So that is, I already know one of the solutions. T equals 0 is a solution. Yes, sir?
The way I was taught to factor, it would be like 2t to the third divided by t, and then that's how you get 2t to the second. Are you saying not to do that?
Well, that would show you what goes in here.
Yeah.
That's probably what you're remembering.
Yeah.
But you need to not forget that t is a factor, or you'll lose one of your solutions.
Oh, like when you're getting the 3 answers. Okay.
Mm-hmm. Yes, exactly. And if y'all will look back, what's going to happen if you plug in 0? Remember, we just reviewed that if it's a solution, it makes the equation true when you plug it in. Look, what are you going to get? 0 minus 0 equals 0. So it is definitely a solution. Now we're going to factor the second part. So I'll do that up here. Now don't forget this guy. He's one of our solutions. Okay. And so we're going to factor, it's a trinomial. So you're either you're using whatever method you learned, or hopefully you guys, if you're not good at factoring trinomials, you're getting some help this week. Don't let it slide. Okay? Remember, I showed you the AC method. I have a video on it, and the Learning Commons can help you with that. You may find people at the Learning Commons that tend to do trial and error. You might like that method better, but you need to figure out which method you like and stick with it and practice it. And you can make up your own problems, because all you have to do is multiply, get the trinomial, maybe put those in a pile and mix them up and pull them back out, okay? And then you can go backwards and factor, all right? And there's practice online too. Okay, so 2t and t is definitely going to have to work. 10 has factors 1 and 10 or 2 and 5. If I put 5 here and 2 here, see, I learned by trial and error. So that's what you see me doing, is I'm just kind of reasoning out where things are going to go and what the possibilities are. I need a minus t in the middle. So if I put the minus here and the plus here, let's check. Please, bless you. Please always check your factoring. Chin and, well, that's the grin, but chin and grin. Okay, we get negative 5t and positive 4t. Yes, that was the correct signs and the correct combination that worked to give me that middle. Now what I'm going to do is I'm going to take the factors. I'm using factoring methods, so now we want to find out what makes each of the factors come out to 0. Those will be our solutions. So these are now linear factors, and I'm just isolating. That's what you're going to find in a lot of equations, is we learn a way to solve an equation, and through doing it, we have to use how we solve another kind of equation. Okay, so we started with a cubic. We ended up with a quadratic. Now we've got linear. They're all solved different ways, and you're having to do all these different things. Okay? Did you have a question?
Yeah. Are you going to be doing trial and error in the class, like when you're teaching?
I am not teaching factoring, because it is expected that you know how to factor. That's why I'm saying, if you don't, that doesn't mean you're lost. You have to get some help this week, because tomorrow, remember, is the drop deadline if you want 100% refund. So you need to figure out, and I'm talking to the online people especially, because they don't have a teacher right there with them. You need to figure out, can I do this semester? Do I have the time to put in to what I need to do? Okay? Some of the really meaty stuff that we're doing is here at the beginning, like factoring. That's a big package there that you're supposed to be coming in with. Okay? A lot of the other things we do, we're all starting at the same level. Okay? All right, so we get 2t equals 5, and then what? Divide by 2. I'll just do it right here. And so I get t equals 5 halves. Okay. And then this one, all I have to do is subtract 2 to get the solution. And let's circle the solution. So we have negative 2 is a solution, 5 halves is a solution, and 0 is a solution. And what that means is if you go back to the original equation, and you could use your calculator to help you, plug these numbers in one at a time, you'll get true statements for all three of them if you did it correctly. So I strongly recommend you do that when you're taking a quiz. And I want to make a little comment about quizzes because I had a student kind of mess up a little because she's online and I didn't explain this. The quizzes don't just cover one topic. They tend to cover usually two, sometimes a little more than that. So don't do the quizzes until you've done the homework that's due that same day. Okay? So she kind of jumped ahead and did quiz 1 before she's really learned the circles. Okay, in that topic. So they're in the modules in the correct order. That's another way to look at it. Okay. So we had 3 solutions. Oh, I need a blank page, sorry. We're going to do an example with a fraction. Now, remember I gave you sort of this flow of the categories of what you need to do with an equation. Simplify, move, factor, yes, divide. Those are general categories that are going to help us, especially when we get to the multivariable equations. But when I'm looking at this one, now, we've got 1/5 x squared plus 13/5 x plus 8 equals 0. All right, I already have 0 on one side. I'm looking at the fact that this is a quadratic, so I don't need to move anything. But I do want to simplify it because I've got fractions. And it would be really hard to factor this thing with the fractions. So that's the first thing I'm going to do is I'm going to multiply both sides by 5 because that will clear out the fractions. Now remember that 5 gets multiplied by all 3. And it really is multiplied on the other side as well. But 0 times 5 is still 0. So when we take 5 times a fifth, we're going to get 1, right? And so we're left with x squared. Now, if you're really bad with fractions, either use your calculator or maybe do the work out to the side. I know a lot of students like to write integers over 1. That helps them keep things straight. So I'll write this as what I'm doing is I'm multiplying 5 times the 13/5 because something's going to cancel, right? The 5s cancel. So what I'm left with there is 13x. And that was really the whole point because I was trying to get rid of those fractions. But don't forget it's 5 times 8. Okay. Equals to 0. Yes, ma'am.
I get it now. So you do 5 times 8 because it doesn't have a 5 under it. So that's why.
Right. Exactly. That's it. Okay, and then you use your favorite way of factoring trinomials because they are so fun. You use that favorite way, okay, whether it's AC method or the trial and error method. But what we would get here is, and this is where anybody who's having trouble from this step to this step, that's where you can go to the Learning Commons with your notes and say, I need help getting from here to here, okay? But what is it? 85 work. Okay. Check the middle. This one's a little easier to check, so we'll just do it in our head. 8x and 5x gives me 13x. Okay. It's factoring method. We have a product equals 0, so we're moving on to what's true then is that a factor would have to equal 0 to have a 0 product. What type of equations do I have here? They're called, are they quadratic? They're linear. And how do we solve linear equations? We isolate the variable. So I'm going to subtract 8. I'm going to start getting a little bit less like writing everything down here for some of the easier ones. So I get x equals negative 8. There's one solution. And then if I subtract 5, x equals negative 5. Now, the original equation had a square. That means, at the most, we could have 2 solutions. Okay? Any question on that one?
We don't have cubes here.
It could. Now, the reason I'm saying it could, for the people at home, what he just asked is if it had a cube, then it would have 3 solutions. It does have 3 solutions, but some of them might be complex. And remember, we don't get into using complex numbers until the second unit. Okay? So don't fill in. You guys are going to, some of you I know how to work with, like square root of negative 4 is 2i. You already know that. Don't do that in this first unit. It says very clearly in the directions, solve over the real numbers. Okay? So sometimes some of the solutions are not real, but there's always 3. Sometimes we have a solution that's the same solution more than once, but that counts. So like you could have a negative 2 and a negative 2. That's actually counted as 2 solutions, even though it's the same number. But in your counting up, to the degree. Yeah.
We don't have to find the restriction because there's no x in the denominator.
Thank you for noticing that. Okay, so the denominator was a 5. There's no way for that to be 0. We looked at another example last time where we had a j plus 9 in the denominator, and that could have come out to a 0, which means there'd be no solution if we had come out with negative 9. Yeah, good. Okay. So this next one, oh my goodness, I have so many people asking me about this type of problem. Especially people at home, because they tend to not, I know the people watching this are not the people I'm talking about, but I have a lot of online students who want to just jump into the homework and not learn the material first, okay? But you guys too, remember, look back at your notes, because I try to cover pretty much everything that you're going to encounter. It may sometimes look slightly different, but if you'll look at your notes and think about it, you'll probably find the answer. Okay, now this is where I want you to think. This is why it's so important to understand the process is based on something that's true. This is not linear, right? We don't divide variables out. You can divide numbers out, but not variables. So what method am I going to use to solve this?
Can you carry over the y to the fifth?
You mean to this side?
Get to make it 0?
Yes, I can do that. I don't tend to like my leading term to be negative, so I'm going to go with your idea. I'm going to take this to the left-hand side. And what were you going to say, Shaquan? Okay, so I'm just going to write down what we're doing. We're going to subtract 49y cubed from both sides. That gives me y to the 5th minus 49y cubed equals 0, because I've subtracted 49y cubed minus itself. So that's where the 0 comes from. So what is that? It's called the zero product property. It's if a product equals 0, then one of the factors has to be 0. That's what we're using. So when you see a weird looking one like this that throws you off, try to remember that's what we're basing things on. So get your 0, and then what would be the next step? Yes, GCF, because you need to factor. So I'm going to factor out a y cubed. Let's make sure everybody agrees with my factoring. Does that look right? Is it multiplying back correctly? Okay, now this, you can think of this a few different ways. That's a y cubed equals 0. Some of you just see what the answer is. What makes that true?
That's a difference of 2 squares.
Actually, it's not. It's just a y.
I was talking about.
Oh, this one is. Yeah, we're going to get to that one. But I mean this y cubed equals 0. Do you see what the answer is? What the solution is to that? 0. Yeah, 0. You're done. Okay. I mean, there's a lot of different ways to think about it, but what cubed is going to be 0? You can just think about that. It's got to be 0. I mean, another way to think of it is a y cubed is a y times a y times a y. So that's 3 factors all needing to equal 0. Remember how you asked me a minute ago about the number of solutions? Mm-hmm. That's 3 zeros. We've got 3 so far out of the 5. We need 2 more. Okay? All right, so now we're going to factor the y squared minus 49, which is, like you said, is a difference of squares. We're actually going to solve that one differently today, that type. But that does factor. It's a difference. People at home, remember, not a plus. Okay? Plus wouldn't factor. It's a difference of squares. And now we're going to set the factors equal to 0 and solve. So this one, can everybody see we're just going to subtract 7? Can we skip over that? Okay, so we get y equals negative 7, 0, and the last one is a 7. And you could use your calculator to check those. Okay? Any question with that? Yes?
It's a difference of 2 squares because of the subtraction sign, right? But if it was a plus sign, then what would be the
Okay, so like if we had an x squared plus 49, there are no real solutions. We're actually going to get into that next because we're going to talk about the square root property. And then we'll see why there are no real solutions. But you really, in 1033, this came up. You know, that you recognize that that's prime. It does not factor. There's no way for that to be 0. I want you guys to look at it analytically. It's saying a number squared plus a number. That could never be 0, right? Do you see why? Because this is always going to be 0 or a positive number because you're squaring. If you add 49, there's no way to make that come out to 0. Okay? All right, so I think we're ready for the square root property. And I'm going to say things... I left the space there. I need to redo these a little bit. All right, let's talk about the square root property. I know that you guys, a lot of you learned how to solve the kind of equations we're going to solve in middle school. And I know that you were told, take the square root of both sides. That is actually not correct. Okay, I know a lot of times when we solve an equation, we are doing the same thing to both sides. And so that's why teachers tend to teach it that way. Take the square root of both sides because we're trying to get rid of a square. But that means you lose a solution. And that's why I don't like it. So I want you to learn this square root property. And if you learn it, really try to keep reading over it. Each time you do a problem, go, okay, the reason I'm doing things this way is based on something that's true. Here's what's true. If, and I think I left you a blank maybe, or no, maybe I just wrote it for you. If x squared is equal to a constant, just meaning a number, let's just clarify that to make sure there's no confusion. Okay, so if we have a squared variable equals a number, then what is true is this number x that's being squared is either equal to the square root of the constant number or its opposite. And look where the negative is. It's on the outside. So let's look at one to just understand what that's saying. Okay, and then we're going to solve using that property. So it's not taking the square root of both sides that I'm going to be doing. I'm going to say, once I have an isolated square, then whatever it is that's being squared is equal to the square root of the other side. Or the opposite of that. And that's where we get the two solutions. Okay? So let me just look at something where you could solve without ever even knowing a method. What squared is equal to 4? 2. 2 squared is equal to 4, right? What else? There's another number whose square. -2. Does everybody agree with that? Those are the two numbers whose square, that's what this equation says, is equal to 4. So by square root method, look at how I've got it set up. X squared equals a constant. Okay? So what's true is that x has to be equal to the square root of 4, which we will simplify when it simplifies, or the opposite. All right? So if you learn this, these problems are going to be easier, and eventually, not until the second unit, but eventually we're going to be using the square root property along with something else that's called completing the square. So try to understand it now, that's why the method that I'm about to use works. Okay? All right, so did I go too fast? Okay. First one. Now remember, please remember, in Unit 1, we're not dealing with I. We're not dealing with I. So those of you that are ahead of the game, you got to remember that, because you're going to message me and say, I put the right answer in and it's telling me it's wrong. Well, it's because you're only solving over the real numbers right now. In Unit 2, you'll write I. Okay, now what's the method? What is the square root property? It says if x squared, or a variable squared, equals a number, then what? X is the square root of that constant, or its opposite. Yeah. Now, when you're on paper on test 1, when you're writing your answer for me, I don't care if you do the plus minus for shorthand, that's fine. But when you're filling it into the answer blank, they'll tell you in the directions you have to put a comma. You can't do the plus minus there. Okay, now based on that, look at how I'm supposed to start out to use this property. So what do I need to do? Good. Subtract 135. Okay, am I there yet? Why? You have a 3. See, we got to get the variable by itself. So we're going to divide by 3. What is that? 45, negative 45? Is that right? Okay, now we are working with real numbers, so we have to recognize that's impossible. B squared cannot, in the real numbers, there's no number whose square is negative. So what you fill in, the real answer is no solution, but what you fill in the homework is does not exist, D and E. Now, I see a few faces that look like they get that perfectly, but there's a few others that I'm not quite sure. Does everybody see it?
Is it because of the negative?
Yes. And because we're only working in real numbers right now. Okay? Did anybody look at the beginning and see that there wasn't a solution? No? Nobody saw that? Because I'm totally for people that can read the math and look at it and go, well, there's no solution to that because look, we're squaring if you look at it analytically, we're squaring a number, that's positive. We're multiplying by a positive number, still positive. We're adding it to a positive number. Any way that's going to come out to 0? No, no way. Okay? I guess we just didn't. All right. So let's do another one. And we are going to have to do a little bit of a review of simplifying radicals. And I remember my 1033 class last semester, I think this was when Thanksgiving happened or something, and they didn't quite learn their simplification of radicals quite right. So if you go back to my welcome email, I sent you guys some links to the videos that have to do with simplifying radicals, so you have some extra resource there. But and we are going to have to do that here. I will do a little mini review. Okay, so start me out. What do I need to do to use the square root property on this problem? I could factor out a 5 if you wanted to. Is there anybody that would have thought of that first? Because that is the GCF. Okay. So we won't do it that way. By the way, let's think about this before we move on. How do I know that I probably want to use square root property, not worry about factoring? Yeah.
Because if you look up 65, you already know 65 is well, 5 plus 65.
Well, I mean, what you're saying is true. That's not really why I know I don't want to try to factor. What were we using? What sorts of situations were we factoring in? Let's look back. Okay, here we only had 2 terms, but once I factored out the GCF, then I had a nice difference of squares that I could factor. Now we could use square root method with that one, with that second factor. Do y'all see it? You know, let's do it real quick. We could use, instead of factoring method, let's put a big or. We could isolate the square, and then we would say y is plus or minus the square root of 49, which, simplifying that, is plus or minus 7, right? We could use square root method on that. So what is the key to knowing that you should use the square root method? Let me show you another one. Let's see. What else did we do? I may not have it here. Well, this one had 3 terms. Could we have used square root method? No. Why? Because it has 3 terms. Yes. You're only going to use square root method when you can isolate a square, right? We could not isolate this square. We'd have a variable on the other side. That's the key. All right, so let's do this one. So it's got 2 terms. Doesn't look like a nice difference of squares. If it did, I could factor if I wanted to. So what I'm going to do instead is I'm going to isolate that squared variable. So I'm adding 625. Everybody follow? And then I'm dividing by 5. Right? And then I'm using the square root property because now I have an isolated square. I have a square equals a number, and so I can say plus or minus the square root of 125. Now let me stop before we talk about simplifying. Is there a question on that, or do you follow it? You guys follow? Okay. That is a correct answer. However, it's not a simplified answer. So we do have to take it a step further. And that's because 25, or 125, is 25 times 3. No, times 5. Times 5. Okay? And with radicals, if there are square roots, if you can factor out a perfect square than you do. So square root of 25 is 5. Square root of 5 doesn't reduce anymore, and so we're going to leave it like that. Okay? And so what we're going to say the final answer is plus or minus 5 square root of 5. Now let's write a note here. This is what's called exact value. It is not approximate. It is exactly what that number is. Really important to understand the difference. Exact value which has been simplified. This is exact value, square root of 125. It's just not simplified. What would non-exact value be?
Something that can be simplified.
No, because that's exact value. Can't be simplified. Good thought, though. Anybody know? What do we mean by something that's not exact? Well, it's decimal. It's approximate, right? So, I could go to my calculator and get an approximation of what that is, right? So, let's do that real quick, because that's how you might want to check your work, is using an approximation. So, if I want to see what the square root of 125 is, approximately, then I do that. Take the square root of 125. My instructions would need to tell you how to round. Different calculators give you a different number of digits. Okay? This is what's called an irrational number, like pi. Everybody remember pi? It has no way to write it as an integer divided by an integer. Those are called rational numbers. Okay? It's an irrational number, and we can approximate what it is. But this is exactly what it is. Does that kind of make sense? Okay, because that's going to keep coming up all semester. Whether you should be giving me exact value or approximate. Okay. Oh, I can barely reach that. I think I'll just... let's see if I can clear the page from here. What's that?
It said clear page.
Oh, it did say clear page.
Or hit Control L.
Oh, okay. I don't know why these are on here. Oh, that's the one I just did. Okay. Right. And I think... All right, you guys help me find it. Where is it? Oh, edit, of course.
Go all the way down.
Oh, yeah. I haven't done this for a while. Okay. Okay, I think we need another example. So we're going to do a new page. Okay, did everybody feel like they understood the last example pretty well? All right, because we're going to add a layer here. We're going to solve n minus 6 squared equals 27. Now, you may as well learn these right now because it's going to come back to haunt you in Unit 2. Because in Unit 2, what we're going to do is we're going to work to get this. All right? So we're going to add another layer. So we need to learn how to use square root method on one that looks like this. So to understand how to solve this one, let's just simplify a little bit. The simpler looking problem where I could use square root method would be that, right? Just a variable squared equals 27. So how do you think I'm going to solve this one? Because we've got something squared equals 27.
Square root both sides.
Do what?
Square root both sides.
plus, except we're not square rooting both sides. Remember, we're using the square root property. So we're going to say, if this squared is 27, then this thing inside that is being squared is equal to the positive or negative square root of 27. The only reason I don't want you to say that, remember, is because you might lose your negative. And we have students that go all the way up to calculus that are still doing that. We don't like that. All right? If you've got a square equals a number, or an expression squared equals a number, and you're using the square root method, you get 2 answers, not 1. All right? Let's go ahead and simplify 27. You guys help me with that. How would that break down?
Wait, so do we take the numbers out of the 3?
Do what? I'm sorry.
Take the numbers out of the 3.
Yes, because what would you, let's kind of parallel it to the simpler equation. What would we do here next? We would say, right. You see that? This number squared is 27, so the number x, that's the number that was being squared, is equal to the square root of 27, or its opposite. So what is it that's being squared? It's the n minus 6. You see it? Okay. So let's go ahead and simplify this. 27, okay, 9 and 3. Square root of 9 times square root of 3 is going to be 3 square roots of 3. Is that right? Okay. So n minus 6 equals plus or minus 3 square roots of 3, which is what we would be finished with on this one, all right? We'd be done on that. Why am I not done here? Yes, because the n isn't by itself because you've got the negative 6. So how do we remedy that? Add 6. Okay, so we're going to add 6. And I would rather you write it like this. I'll tell you why. Put the plus 6 on the end. I'll show you why after you write it down. If you write it after the plus minus, now remember that means 2 different things, right? That's 2 solutions there. Let's write down what they are. We have 3 square root of 3 plus 6, and we have negative 3 square root of 3 plus 6. Okay, in another unit, I'm going to show you how to find those on the calculator to make sure you got the right answer. Yeah?
Wouldn't that just be 1 time like plus 6? Well, actually, no.
It's both of it. See the plus minus here? That's where it is. So when we add this is shorthand for 2 different solutions. So that plus 6 is getting added to both. Yeah. All right. This is why this is the way I was taught, and it might be the way you were taught, is to write it like this. Put the 6 at the front. And that's the way it's going to look when we do the quadratic formula in the second unit. It's going to look just like that. But the problem is students will add that 6 and that 3. Why is that wrong?
Because it's the whole thing, not just the 3.
Yes, and this is a product. Remember your order of operations? You guys know this, I know. You learned it somehow. The way I learned it was, please excuse my dear Aunt Sally. Okay? So that's multiplication comes before addition or subtraction, right? This is a product. So you can't add the 6 and the 3 there. You just have to leave it like that. That's why I say if you add it on the end, you won't make that mistake because it won't look like you should add it.
No matter how we put it.
No, it will not matter. Okay, now is there anything anybody's wondering about on this?
Is that the final answer? No.
Yeah, that's the final answer. Or you could write it this way, but separated with a comma. Yes? Right. There's 2 answers. That's the whole point. That's why, and I'm not trying to give anybody a hard time about saying take the square root of both sides, because that's the way you've been taught. That's not what we're doing. It's based on something that's true. If a square equals a number, then the thing that was being squared is equal to the square root of the number. or its opposite. That's why you get two answers. See, if you just say take the square root of both sides, why would you put the plus or minus? Right? Okay. All right. Let's do maybe just one more of those. I'm going to skip over the fraction for now. Have I shown y'all how to use the fraction key? I did. Okay. I'm going to go check the time just a minute, but I want to make sure we get to the other types, these types of equations. So, we got, how much time do we have? 20 minutes. Okay. Yeah, but literal equations you're going to want to see me do more of. All right, so let me skip to 5. And you've got number 4. I've got the steps in the key, so you can take a look if you have trouble with the fraction. But I wanted to do this one because it's not isolated yet. So I wanted to make sure we took a look at that. You see how it's not isolated? The square is not isolated? That's the whole point of the square root method. It says if we have a square equals a number, then we know something. That's why I've got to add the 15 first. Remember, guys, we're not going to be like Dory and say something about jellyfish, okay? I'm moving on. No. Make sure you understand what the truth is behind what you're doing so that you understand the process. Okay, see, I have a square equals a number now. So based on the square root property, I know what? I know 4x minus 2 is equal to the positive or the negative square root of 15. That's really two separate statements. I'm allowing us to do the shorthand unless you need me to write it out. Does anybody feel like they need me to write it out? Okay. Now what? Good. Add the 2. We'll add it on the end, okay? You could put it at the beginning. Just remember you wouldn't combine it with anything. And it's not under the square root. And then what? Good. There you go. You're done. Oh, one other thing. What I'm writing right here is correct. When you type it in, if you're, you know the tablet that you can use in the answer box, you know when you click in the answer box? Okay. There's a fraction tablet that you can use, and then you could type the top in over the bottom. It'll be two separate answers here. If you don't want to do that, you can use parentheses, but remember to use the preview button. Make sure you're typing in what you think you're typing in, and you would need, that's why I'm putting them in green, because you would need a parenthesis here and a parenthesis there to type it in as the correct fraction. Now, is anybody thinking that simplifies more? I know you are. Tell me if this is right. Is that the same thing?
Yes.
It's both are over that. That's a very common mistake. If a 2 doesn't factor out of the top, don't worry about simplifying it anymore. Or not a 2, but if something doesn't factor out of the top and then cancel, don't simplify it anymore. Now, if you wrote it like, rewrite it, like this, that would be correct because it's the square root of 15 over the 4 plus the 2 over the 4 gives me 1/2. That's correct. But if you left the 4 off, that's not correct because both of these are over the 4. Okay? That's just a real common place to make a mistake. Yes? Oh, if this had a 2 here?
No. If it was plus or minus square root 15 multiplied by 2 all over 4, can I then do the cancellation or no?
Oh, you mean like times 2 like that? Yes, because that is a product.
Okay.
With products, you can cancel, but this is an addition. So every term on the top has to be over the bottom. Okay. Let's let that. That's what she was asking about. Okay. So the literal equations. I wrote y'all because there's one problem, and I'm pretty sure this is the only one we're having a problem with all the homework, almost positive. We reported it last semester, and it's still not fixed because I've already had a student get the right answer and get marked wrong. So look in your, I can't remember off the top of my head which number it is, but look in your email because I wrote you and told you which problem it was in the homework. So just skip it. It's just one problem, and you're going to have like 300 points in your whole homework, so, or more than that even. Okay, so I'm going to go on. I know I have a little extra practice in the notes. We don't ever have time to go over that. So I'm getting to the literal equations here. And this is where we're really going to want to think about simplify, move, factor. This is really important. People try to do that too quick. And then divide. They'll divide up here instead of at the end and get things wrong. So what we're going to do with this first equation is we're going to solve y equals 9 over 4 minus x for the x. We're going to rearrange this equation so it is solved for x. Now, we're not going to get a number this time. We're just going to have a different looking equation. So what does it mean to solve for x? Yes, it means you're going to isolate the x. Good. So your goal, try to keep the goal in mind, that also helps with this process, is you want x equals anything that doesn't have an x. Now, all the same things that you've been doing with equations are allowed. You can multiply the same thing on both sides, divide, and you can add, subtract, as long as you do it to both sides. You can simplify sides. All those things are still okay. So what I'm going to start with on this one is I'm going to rewrite y as y over 1 because more of the students follow this type of problem if we do that. Now that's something called a proportion. Do you remember that from way back when? You probably had to do them if you went to Florida schools on the FCAT or something. Okay. So if it's a proportion, cross products are equal, right? Let me just show you the y back here. How do we know these two fractions are equal? Well, one way we can tell is their cross products are equal. That's how you can tell fractions are equal. We use that truth to solve a problem like this. Why am I doing this? I'm on the simplify step. I don't like fractions. I always think about simplifying fractions. So we're going to cross multiply. Now, the other thing I have seen a few students do is they forget about the fact that there's a left and a right side to these equations. Okay? So on the left, I'm going to put the product y times 4 minus x. And on the right, I'm going to put the 9 times the 1, which of course is just 9. 1 times 9 is where I'm getting the 9. Okay? Now, that's not simplified because I can distribute. So that's the next thing I'm going to do is I'm going to say that's 4y, only because I like the number being in front of the variable, minus, and I like to go alphabetical, so I'll write that as xy equals 9. So what have I done? I have simplified my equation as much as I can do. That is now simplified, so I'm finished with that part of the process. Okay? Now, the other thing I want you to understand is in that flow there, the simplify, then move, then factor, then divide, is you don't always do every one part of that. So let's see if we need to do it on this one. Well, we want x by itself. We're on the move step. Yes, I don't want this 4y here because it doesn't have an x. So you have a choice here. You could either move the xy and also move the 9 to avoid negatives, or we could just go ahead and say, nah, we'll just deal with a negative in a minute. Let's do it that way. Okay, so we're going to move the term that doesn't have the letter that I'm solving for. What am I left with? Negative xy equals 9 minus 4y. So the purpose of the move step is to get the variable you're solving for only on the left. And anything that doesn't have that variable will be on the other side. I said left, but the sides don't matter. What matters is if we're solving for x, we've only got x terms now and only got non-x terms now. Now, I don't need to factor on this one. I'm ready to move on to divide. Does everybody see that? Because I only got one term. If you've only got one term, you don't need the factoring step. So how do I get an x by itself? What is it that I need to divide by? By what? Good. Divide by negative y. And for those of you not following why they said that, it's because we want to have x. So if I've got a negative, I need to divide by a negative, so it'll just be a plain old x instead of a negative x. So what does that leave? It leaves x, because negative over negative is positive. The y's cancel. And that's over 9 minus 4y all over negative y. Now, I know some of you work your problems kind of a little bit ahead of me. If you had moved your x to the right-hand side and the 9 to the left, your signs are going to be different, and that's okay. If you got x equals 4y minus 9 over y, yours is actually the same answer as ours. Let's see why. Multiply the top by negative 1 and the bottom by negative 1, because that's okay to multiply top and bottom of a fraction by the same thing. Negative 9, negative 9. Positive 4y, see it? And negative y, negative 1, positive y. So if all of the signs are the opposite, you've actually got the same equation. And you probably need to know that as you're working the problems, because you might go, well, I plugged this in, it's counting it right, but that doesn't look the same. Well, if all the signs are different, then it's the same thing. Yes?
So either one of those work?
Yes. Okay. Also put yourself a note here, because I have a lot of students who miss the directions on this, on the problems that have to do with this. It will say, enter as an equation. And you'll come to me and say, I got it right and it counted me wrong. Well, you're not following the directions if you put in just this. That's what's wrong. Because you got to put the whole equation in. And it says that in the directions. Okay? How am I doing on time? Okay, good. I want to get to the hard one, which is the next one. Okay? And we've got a couple extras too. Number 4 is the one that's got the bug in it. Okay, this one is super duper important. Solve y equals 9x plus 2 over 5x minus 9 for x. We're rearranging this thing. Remember, our goal is to get x equals anything that doesn't have an x. We're going to follow the process. Simplify, move, factor. This is where some of you are going to see this and kind of go, what? All right. Divide. This problem shows me how well people understand algebra. So if you're having trouble with this problem, come see me immediately. It will come up on test 1. I promise you it will. And it's going to come up again. So do not let it slide. Okay. The thing I don't like that I consider not simple here is the fact that it's a fraction. And it is kind of complicated, right? Because I got an x on the top, an x on the bottom. How in the world do we take care of that? So I'm on this simplify step. So what I'm going to do is I'm going to write y over 1, and I'm going to cross multiply. This is going to be one step beyond that last one. Okay? So we have y times 5x minus 9 equals 1, so I'm going to leave it off, times 9x plus 2, because 1 times anything just gives me the same thing back. Okay? Now, I will have students multiply this out and then try to divide, and you've got to follow this process to get there. We're still simplifying. I got rid of the fraction, so what am I going to do next? Good. Distribute. So we have 5xy minus 9y equals 9x plus 2. We're done simplifying. That is now what I'm saying is simplified. As much as we can possibly do on those sides. So now we're on the move step. And this could get very messy if I made you write all the steps out. So what I'd rather do is I'm just going to say what I'm doing. I'll write it over on the side, and we'll move things. So you're going to tell me, should I keep it or should I move it? With the goal in mind, which remember was x equals not x, right? Okay. Keep or move? Good. Keep it because it's got an x. Keeping it. Keep or move? Okay, now how do I move it? I have to add. Good. So we're going to move. So what we're going to do there is we're going to add 9y to both sides, right? Let's keep the equals here. All right, so I'd have a 5xy, and I'm just going to go ahead and write the 9y here because I'm moving it by adding it. Okay, now you're on the other side of the equals. Do I want to keep 9x on that side?
No.
Okay, good. I want to move it. How do I move it? Okay, subtract 9x. And what about the 2? We're going to keep it. We have moved. We've done the move step. That's what we wanted, was to have x terms on one side, non-x terms on the other side. Okay? Now here's the magic step. This is the one where people get confused. Factor. What is it you're trying to do? You're trying to get x by itself. So I just want to factor x out. You may even be leaving aside your good factoring skills here. If there was a 3 to factor out, I don't need to do that. I just need to pull the x out. Because look. Okay, if I factor out the x, you see it? What's the last step? Divide. What would we divide by? Okay. And then you're done, right? So, see? We can just divide out. And so we get x equals 9y plus 2 over 5y minus 9. That's the equation we would enter as the answer. It is rearranged and solved for x.
Instead of us going through all those steps, so we just divide what you did because it's 2x.
There's really no shortcuts on this one. I'm sorry. You really need to show me. This is one of your longest problems in this class, okay, that requires the most steps. Okay? And you guys go ahead and use the key for the last two. Remember number 4, you might get a version that's similar to that problem that works, and you might get one that doesn't. We don't know if it's the subscripts that's messing it up, but the company hasn't figured it out. So you could skip that one and you'd be fine. But look at number 3 and work through it with the key.
Bye, Miss
Okay? You too. I'll see you guys Tuesday. Have a good long weekend.
So we're starting the next section, next class?
We will be in circles and distance and midpoint formula next. Yes. So
So
bring.
that's the next module.
Yes, the next module. So bring those notes. Let me turn the thing off. Bye.